All right, this is a tutorial for the physics classroom concept builders that have been assigned for forces. Um, there's 3 of them. There's different levels to each. Please look on the assignment to make sure you know what you need to do, although I think I'm going to hand you out a sheet saying that as well. So when you go to the physics classroom, remember you're going to log into your account over here. Then it'll ask you about your classes, which I think you should only have one. And within those, there are going to be certain tasks. Look to make sure it's the forces tasks. They should be coming due shortly. Okay. There's others which we've already done, but you don't have to do those. At any rate, the 3 tasks are balanced and unbalanced forces. So when you get to that point, you're going to go ahead and click on the concept builder. I'm asking you to do the master level and the wizard level. Again, if you don't do both of them, you'll get some points, but not as many as if you do both. You could do the apprentice level. It's not going to be for points because I think it's way too easy. But again, your call if you want to do that to help you out. So I'm going to do a sample on the wizard level. I'll maybe do a couple of these. Remember, if you want to get help, you can always go to the Help Me menu. You can think about a particular question, general situations, and sometimes there's links, and you can go to actually to the physics tutorial that has a number of things about the reading. For example, you could go Newton's laws as well. Okay, so I'll go back to that home page. Anyhow, at this point, I don't need the help menu, I think. So I'm going to go to this. Balance versus unbalanced, blah, 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 blah. Hotspot. The motion of the object is represented by velocity time data. So if I look at this, I'm going to say this thing is 0 meters per second, 2, 4, 6, 8, 10. So it's definitely speeding up. So therefore, as long as I don't have constant velocity, that's unbalanced forces. This is a constant velocity. It's a velocity time graph, so it's constant. Now I'm going to select unbalanced, even though it should be balanced. So this is the correct answer over here. Uh-oh, drats. So what you're going to notice now is, remember, when you miss one, this is going to become a red box. Whenever you hit that again, you're going to have to get 2 correct for that particular box number. Okay, so it is helpful to you to get them right on the first try. Each person's questions are slightly different, but they're similar enough where you could help each other if you have questions. I do ask, obviously, you do your own work when you're logged into your account. So this looks like balanced vertical forces, but unbalanced horizontal forces. So if I have unbalanced forces, it says it's a rightward moving object. So if it's a rightward moving object and the force is to the left, it should be slowing down, unbalanced. So sometimes you definitely do need to read this information pretty carefully. So that's an example of those. The next concept builder are the force and motion. I'm asking you to do the vertical motion, horizontal motion, and then combine for both of them. So I think this is the easiest one. This is the second easiest. This is the more challenging one. So I'm going to do an example with these. So in this particular case, the object is experiencing force is shown to the right. Each arrow represents the force in a specified direction. The length of the arrow represents the strength of the force. Which dot diagram represents a possible state of the motion of the object. Select all that apply. So these look like balanced forces. So that means the object could either be going at constant velocity or be at rest. So that agrees with this dot diagram, which is kind of like a motion map without arrows, this dot diagram or this dot diagram. So I think all 3 of those are possible. If I check another one here, this now has a greater force down than up. We don't know what direction something's moving. Can't be at rest. Can't be constant velocity here. Can't be constant velocity here. If it's moving upward and there's a net force downward, that makes sense. The dots would get further apart as it goes up. In this particular case, this would not be correct. Oh, I lied. This is correct because the dots get closer together if there's a force down but you're moving up. If you're moving down and the forces are acting downward, the dots are going to get further apart. And again, notice this arrows on the dots represent the direction that the object's moving. Notice, by the way, for both of these, even though the directions are different, the spacing of the dots looks the same. So if you're going down, you're speeding up and the dots are getting further apart. If you're moving up, you're slowing down. The dots are getting closer together. Okay, so again, that's just an example, one of those. This is just a horizontal example. So you could think about which of these would be true as well. And yes, you can have vertical forces and horizontal motion. The last one is which of these does not belong. So it's going to give you a number of representations and ask you to interpret which one is different than the others. With this one, I'm going to ask that you do the apprentice level only, the master level only, the wizard level only. They're each for a certain number of points. You do all three, you'll get more points. So I'm going to go to the wizard level. I'll try to do 2 of these. So one of these representations is not like the others. So this shows an object moving the positive direction and speeding up. This shows an object moving in the positive direction and speeding up. This shows an object with an unbalanced force pointing to the right. That's consistent with these two. This shows an object moving in the negative direction and slowing down, so that is not like the others. Okay, here I have 5 representations. So this is moving to the right but slowing down. That is consistent with an object with a force pointing to the left, since we don't know the direction of this. So far, so good. Here we have an object. Its position is getting smaller and it's getting less steep. That is also consistent with an object, but that object is moving to the left because we have a negative slope on this. So that does not seem consistent with these. This shows a positive velocity getting slower and slower. That's consistent with this and could be consistent with this. This one shows over time the positive velocity is getting slower and slower. So I think this one's the odd one out because this negative slope on the position graph indicates a negative velocity. All right, so that was a tough one. So once again, you can always go to the Help Me menu here, look at the directions, things like that. Okay, so hopefully this is helpful to you when you do these, especially if it's one of the days where I'm absent. Thanks.